Hey folks, welcome back to another video. Today we're going to tear down and inspect a 700R4, and this one's going to be a little bit different in the sense that this transmission was recently rebuilt. And when I say recently, I mean literally within the last 20 miles or so. Customer shipped this to me from Illinois. He is an auto repair shop owner out there, and he is also the builder of the transmission. So basically the situation here is that when he installed the transmission, went to go for his test drive, put it in reverse, he noticed a pronounced delayed engagement. Took a lot of RPMs for reverse to fully engage so that he could back the truck up out of his shop. Put it in drive, engagement was normal, but he observed all of the upshifts were rather late. So 1, 2, 2, 3, 3, 4, all significantly later than what he was expecting. So basically, he sent me the unit and he asked me to do a few things. One, diagnose the delayed engagement, figure out what may have gone wrong. Secondly, figure out why it's shifting late, and at least insofar as what I can find in the transmission that could cause that. And then thirdly, he also remarked that the shifts were rather soft, so he wanted me to provide a more aggressive calibration for a little bit firmer upshifts. So, we'll go ahead and do all those things, and then as we go through the unit, we'll see what additional parts and components that he may need, or, if there's any damage, what we would need to replace. Now, he did mention he threw a fair amount of upgrades into this thing, so curious to see what all is in there, and, we'll let him know what else I may recommend based on his application. Now, the vehicle in question is a 1970 GMC pickup. It's a 4x4 vehicle, and it's equipped with an Atlas transfer case, or at least I think it's an Atlas. It's got a stubby output shaft, and it looks just like all the other Atlas output shafts that I have dealt with. So let's get a little bit closer to the bench, and we'll go ahead and begin. Taking a quick look around the case, we can see a couple things right away. One is obviously the paint job that he gave it. He took the time to mask things off. I don't see any overspray on the gasket. There's a new case connector. That's always a good sign. And then as far as the output shaft, as you can see, it's a billet steel shaft, stubby. Again, typical of Atlas transfer case. The one thing I noticed is that the governor gear was not replaced, so we'll go ahead and give him a new gear. And come around on the passenger side, we see a Sonic servo assembly installed. This is going to be your super hold servo. I believe he installed both the second and the fourth gear component, but we won't know until we have it out. Alright. Like I always tell folks, you always want to do a hasty end plate check before you start tearing into the transmission. And as soon as I got it out of the crate, that's what I did, and I noticed immediately that this thing had like no end play whatsoever. So you should be able to feel some movement as you're pushing and pulling on the shaft like this. Alright, spec for these is 15 to 30 thousandths. At 15 thousandths, you can feel that. You can even feel it at 10, it's almost imperceptible, but if you really push and you really pull, you'll feel 10 thousandths worth of end play. This has absolutely nothing. And the shaft itself is very hard to turn. I mean, very hard. I had to use vice grips, and I didn't turn it anywhere near a full revolution because I don't want a chance on damaging anything. Alright, so he also did a nice job kind of plugging up all the ports where things might leak. So, again, it's that kind of attention to detail that you do like to see. We'll have to check and see what the pump looks like. I believe he had the pump reconditioned, in other words, either remanufactured, purchased off the shelf, or had a machinist go through it and, mill the surfaces. Alright, I'm going to approach this disassembly a little bit different than I usually do, in that I'm going to flip this thing upside down. I have like a soft pad because honestly I don't want to mess up the paint job, because then I gotta correct it. And I'm going to put a stand on the back side. I'm going to take the pan off, and then I want to see what the band clearance looks like. The customer, has not rebuilt transmissions, at least not these transmissions, as far as I know, as from when I can recall our conversation, all that often. So it's like one of those things where every once in a while he'll get into one, either for one of his customers or for himself, but it's not something he does on a regular basis. So just want to keep that in mind. Alright, so I'm going to do the best I can to not make a huge mess out of this thing, and then we'll get it up on the stand and we'll start taking the pan off. Alright, so we're all set. It's on the stand, and if you're able to see any of the fluid, this is what it looks like. I mean, it's black, it stinks. One or more applied elements bit the dust in this thing. And he did mention to me that when he went to set up his TV cable, he basically pulled it as tight as humanly possible and then more or less left it as is and then drove the vehicle. He did not do a line pressure test to confirm or deny that his settings were where they need to be. He will when he goes back with it, and we did have that conversation, but as far as right now, that was not done. All right, time for the big reveal. Okay, so we have significant applied element damage here. I mean, this is significant. So there's a drain plug here with a magnet, and it looks like there's I guess a little bit of leftover weld. I don't know if he welded a stop to it. Actually, it looks like he did. So he didn't mention that that was leaking or not, or he didn't mention it, so I don't know if it's leaking. Nothing was coming out of it when I pulled it out of the crate. Okay, standard filter. Let that drain. Alright, so we have a lockup set up here. I'm not really sure who makes this or what that is. Maybe Superior Tech. I'm not, again, not super familiar with what I'm seeing. But he does have lockup. He did mention that he has a means to lock the torque converter when in high gear. Alright, so 13 millimeters on the pan bolts, 10 millimeter on all the valve body bolts except for the auxiliary valve body. That should be an 8 millimeter, 10 millimeter here on the 1-2 accumulator housing. Alright, let's see what kind of accumulator setup we're working with. So it looks like a Sonex pinless accumulator. Okay, we'll have to extract that out in the compressed air once I fire up the air compressor. Alright, TV bracket. And this looks like a little bent out of shape as well. A little bit bent. So may need to substitute. Okay, this wiring harness I'm not going to reuse. That's going to be replaced. The solenoid. So that's just assembly lube. But this thing's seen much better days. I mean, the plastic frame here is all coming apart. So again, I hesitate to reuse any kind of electrical components in transmissions for any reason. Okay, 10 millimeter on the feed pipe. This goes from your auxiliary valve body to your pump. This is for your forward clutch feed. So if you want to test your forward feed and you don't have a test plate, once you have this pipe out of the way, you can just put compressed air right here and you can check the apply of your forward clutch. Alright, if you're not familiar with these units, just simply take a picture before you start taking bolts out and removing things. It's just good practice so you know exactly how they go back together. I mean, not a whole lot of complexity with these transmissions relative to others, but like I said, if you're new to transmissions, period, then, you know, it'll look fairly complex to you unless you've, you know, are somehow either a mechanical savant or you've done your homework and, you know, researched them. Alright, so I want to pry this feed pipe out of the way. You want to be real careful with it. I'm going to have plenty extras, but you know the idea is you don't want to break it. Just get under here, start levering up on it. And I don't know if you can see this, so let me kind of reorient the case a little bit. What I'm seeing there looks like some sort of sealant for the feed pipe. So there we go. It is completely unnecessary to do this. I have never seen one of these actually leak to the point where it's detrimental to function. So we'll get rid of all that sealant, and then when we go back with it, we'll just install the pipe as is. Sand sealant, or whatever it is. Alright. There's a harness. So he's got these two connectors here. I'm going to recommend that we go back with it, and either we're going to use a rostra harness, or we're going to purchase an external lockup kit that already has the internal harness assembly that I can install, and then, you know, we'll use this same sensor switch for the high gear and or overdrive, excuse me, and that will allow us to run whatever lockup kit he has on the external side. So I'm not sure exactly what I'm going to do there. I'm just, you know, thinking out loud at this point. All right, 10 millimeters, all these other bolts. So we can start this. And actually I'm going to take the main valve body off first, then we'll do the auxiliary. All these bolts for the main valve body are the same length. At least they should be. So when you're installing your 700R or your 204R, what you want to do is have the pan off, and you want to make sure that the TV cable itself, the TV cable itself is adjusted so that there's a little bit of preload on this plunger on the TV sleeve and you know, plunger here. So your lever, your actuator, should be a little bit preloaded on the plunger. Okay, I believe this is a Sonex plunger and sleeve kit. I've been installing them in all my 700R4s lately. They're great kits, and it's an excellent way to mitigate poor line rise characteristics, and you know, kind of checkmate that problem before it even materializes. Okay, there's going to be 2 check balls on the valve body itself for these auxiliary units. And if he put a 3rd check ball here, which it looks like he may have, that would explain why we have problems. So it's a check ball here. There should be 2 check balls here. So he did have a check ball there. He had his check ball here. And here's the other check ball. So he did have 3 check balls in the valve body. He should have only had 2 for auxiliary valve body. Auxiliary valve body, this does not have a check ball. Only the non-auxiliary valve bodies is the check ball, supposed to be there. Because as you can see, he plugged the hole. And the general rule of thumb is if you have a bathtub, you should have 2 holes. Alright, no big deal. I mean, yes, it's a big deal in that it likely caused the problem, or at least significantly contributed to the problem that he had reported when it comes to reverse. But, we all make mistakes, and none of us are perfect, least of all me. I mean, I have a few mistakes out on the channel in my videos where I had to make commentaries so that folks don't repeat them, as they're watching my videos, because I think one significant one. But the point I'm making here is that these things happen. It's not the end of the world. It's a mechanical device. It can be repaired. All right. Auxiliary valve body. We have a check ball. So I'll always have a check ball here. Okay, they must always go back in. So he has the correct spacer plate gaskets used. Always use your green stripe or yellow stripe gaskets with auxiliary valve body 700s. And then he has the Transgo 700P plate. Okay, Transgo's instructions will have you install slugs in certain locations, and those locations are based on what generation of 700R you're working with and what generation of valve body specifically, because you can take a second gen 700R4 and equip it with a first generation 82 to early 87 valve body that has the mechanical torque converter clutch control valve mechanism installed, or it's provisioned for it, and that will allow you to run a purely 100% mechanical setup, including torque converter clutch apply. You would not have to run a standalone internal-external lockup kit or any kind of computer control to manage the torque converter. The other option is to go with a non-locking converter and conversion kit, which you would install a different valve into this location in the pump. So he's got the 2 holes plugged. Okay, this other hole here. Okay, this is for this check ball, which again, I'm seeing assembly lube in here. So, this would be a less severe mistake if he had put a check ball there, but I don't see a check ball itself. Maybe he caught that mistake before, it went back in. So check ball here, 2 check balls here, your safety check ball here, and in 82 to 86 units, you will have a check ball here. Okay, I'll flash a diagram that will show all of the check balls and their specific function so that you have that. But moral of the story is that with 700R4s, you need to know what check ball configuration that your particular unit takes. 82 to early 87, well actually 82 to 86 is one, early 87 is another, because 87 was a changeover year, and so you may have an 87 case and it has an auxiliary valve body, and sometimes it has that large upside down U-shaped crease on the passenger side, sometimes it doesn't. So when it comes to 1987, you have to be on guard, because you may have one check ball configuration where you may have another. Okay, sometimes these get stuck in the case, so I'll have to deal with it later. Alright, let me get the linkage out of the way, and then I'm going to check band clearance. Okay, so 13 millimeters here and here. And the one thing that I'll mention is that the shaft spins freely in the direction engine rotation. I'm not even going to bother spinning it counterclockwise. It's going to be damn near impossible to do by hand given how short it is. But it's not bound up. Well, it is because I'm in park, but it's not bound up when I'm spinning it and park is not engaged. All right, this is 15 millimeter on the nut. And then grab your flat blade screwdriver and take off your band style spacer. And that will also allow you to pry the rooster comb forward so that you can get that off. Okay, the rooster comb, if you're not familiar with it, and the parking rod, the orientation is just like this. Oops, sorry about that. Sometimes these will not want to come out. They will mushroom here, and then they will mushroom on this side too. So I'll take a grinder with a wafer pad, like that grinder that's on the wall. It's just out of your view. But I'll smooth them out so that when we go back with it, it doesn't, you know, mar up the case or whatever. I mean, sometimes it's going to do that no matter what, but you can, you know, at least reduce the problem somewhat by smoothing out the engagement flats. Selector shaft steel, small pry bar, and all I gotta do is pry it out. Okay, so let me reorient the case and the camera so that we can get a little bit better view of the band itself, because I want to see if there's any issues when it comes to the clearance in the band. Now the two accumulator springs that you see here, these are both Sonic springs. This is the fourth gear, is the second gear is a little bit longer. So Sonics makes two such springs for the 1-2 accumulator housing. They make the spring you just saw, which is more or less your standard spring, and then they make a super strong spring for a really stout 1-2 shift, and that's something I would never use in a factory stall. I stall only pretty much. Big heavy truck will absorb shift energy better than a light passenger car, so you can be a little bit more liberal when it comes to your feed hole calibration. So just a quick peek before we move on. This is going to be your 2-3 feed. This is your 1-2 feed. This is going to be your third gear exhaust and your band release. So depending on what else he has going, this is typically drilled to about 70 to 75 thousandths, and you know, this is typically drilled to 110 on a factory application. I mean, that's generally speaking a good way to go. And then this is sized based on application. I'll probably leave this alone, assuming he has a super hold servo in here. I'll leave this alone for now. It looks like it's about 90-ish thousandths, 85 to 93, somewhere in there. And then your fourth gear feed is also 110. Now, given he wants a firmer upshift, depending on what I see in the case, we'll decide what I do. But generally, if I'm wanting to be on the stout side, I'll increase those numbers by about maybe 10 to 15% over that set of figures I just gave you. Okay, and valve body is faceplate gasket. You could just tell which one is which. It'll have a C here for case, and then the valve body to plate gasket will have a V. Okay, here is the band. Let me get a little bit closer so you can see. Okay, so a little bit closer here, we have the band. So I will make a paint mark on it so we can see it. So when it comes to band clearance, you want to see between 1/8 and 3/16 of an inch travel longitudinally of the band on the drum. So, you know, forwards and backwards. This does not matter what kind of servo setup you're running, whether it be factory or aftermarket. Doesn't matter what pin you're running. It just doesn't matter whether it's 700R4 or 4L60E or whatever variants, you know, in that transmission family. So I'm gonna take my screwdriver. I'm gonna pry forward as much as I can, and then I'm going to pry rearward. Alright, now what I'm going to do, that looks like it's about 1/8 to me, maybe slightly less. What I'm going to do is grab a slip yoke and stick it on the output check and see if I can turn everything counterclockwise, because that will allow the reverse input drum to turn. And if I can turn it without any signs of binding, that would tell me that the band clearance is actually perfectly set to where it should be. Alright, so this is clockwise, now we're going to go counterclockwise. And you should be able to see the drum moving. I mean, it's a wide band, so there's not a lot of drum exposed, but you should be able to see it moving. For what it's worth, I feel no binding whatsoever. So whatever else may have gone wrong in here, it's not likely the band is the source of the problem. Okay, now I'm going to go ahead and start taking everything out of the case. I want to reposition the camera, and I think I've given up on the hope of having to potentially repaint or refinish, and I'm just going to throw it on the bench. You know, I'll be into it for, you know, a little bit of paint work once the case is cleaned and dried. Okay, first things first, I want to get the governor out, take a closer look at it. So one thing I also noticed is that, well, never mind. I was going to say there is no governor clip here, but there is no hole in the case for it. Some of these cases don't have the governor clip, and you really don't need it. I've never heard of a governor actually coming off of one of these cases if it's properly installed. So I'm just going to try to get inside, and behind rather, and go around as, you know, to the extent that I can, and then once it's to the point where I have a good amount of gap here, I'll switch to a pry bar. And then just tap it out the rest of the way. And it looks like we have some RTV. Okay, no RTV is necessary here. In fact, I think we may have only RTV and not a seal. Yeah, I only see RTV here, so I'll deal with the RTV later, but you always want to install your machine cut seal here. They're square cut seals. You never want to just do RTV. Alright, so let's check the governor. Okay, I want to see that valve move and I'm not seeing it. So the governor will need some work. This little roll pin here, you punch that out, you pull the gear off. You know, you withdraw the valve, and then you can go into the inner diameter with a bench buddy and kind of hone it out so that the valve's no longer sticking. Alright, I'm going to turn it around. This servo's going to have to come out. Okay, I want to be careful, I don't want to mar up the surface of the piston. And then just yank on it. And then there's going to be an O-ring, just like any other servo assembly. You'll have your cover O-ring, and you can come in with a pick. And you can grab at it. And withdraw it. Okay, if I marred up the O-ring, I just put a new one on. Okay, you have your spacer, your washer. This is your 4th gear piston. And then looks like he has the Corvette servo installed, which is fine. You know, Corvette servo in use with an aftermarket billet servo is a great combination. Most of your cost associated with these aftermarket servo assemblies is in the second gear servo. And in most cases, you do not need the second gear servo component. You just need the fourth. If you're doing something moderate to high performance, if you're doing something like all out race, a lot of power, I mean, we're talking 500 plus horse, then you want to go with a billet second gear servo in the aftermarket. A Viton seal, it's always good. He has the notches for the shift kit. So, see here. So that's a standard fourth gear return spring. If it was aftermarket, it'd be a little tougher. You may put one in, just a little bit better release characteristics. And these tend to get kind of soft over time. They lose their spring tension. So again, high performance or, you know, specialized applications, those are the kind of things you want to deal with and tend to. All right, if this was not brand new, we would replace with a Corvette servo. I'll deal with it later. All right, now I'm going to reorient the case again so that we have the barrel facing us and start withdrawing everything, beginning with the pump assembly. All right, 13 millimeters on all your pump to case bolts. All right, to remove the pump, what you want to do is just take your pry bar, stick it kind of right here, and then just simply pry it forward. What you want to do, if possible, is prevent the reverse input drum from coming with it. So just kind of go back and forth. And I was not successful. The reverse drum is wanting to come with it. And the reason I say that is because you have to disengage the band first before that drum can come out. But that didn't happen. Okay, here is your non-selective washer. It's got sealing rings, and looks like I see what may have happened. So it looks like the scarf cut orientation may or may not have been correct, but regardless, yeah, it was in there like that, I think. I'll have to replay the footage, but regardless, you had a laceration right there. And these can be tricky. So if you're going to run the scarf cut sealing rings because you don't have the sizing tool or you don't want to mess around with it, you always want to pre-wind these. Okay, and then here's how the scarf cut should be once this sealing ring's installed. Should be just like this. And then you want to wind it up tight, real tight, so that when you put it back on, it stays nested into position so that it's not proud and interfering with the stator, you know, installing into the reverse input drum. So my guess is the reverse input clutches are smoked, and hence the reason for delayed engagement. All right, let me look at the pump now. Just gonna take it apart. Let me change camera angle. See what kind of pump is installed. 13 millimeter, or what kind of rotor and slide, I should say. 10 vane is standard. 13 vane is popular to do. Okay, we have some scoring here. So we will stick this on a lathe. Let's see what boost valve and reverse boost valve have been installed. So 470 or 472 is popular. I use them all the time. Your half-inch boost valve is for like your high-performance street strip full race type builds. So what you don't want to use is the original boost valve. You know, they're 420 thousandths. It's not so much the size, it's the fact that it is likely worn out from decades of use. And this is stuck in there. Alright, so O-rings for boost and reverse boost. Okay. Side faces in. So he did mention he installed the Sonic zip kit. Now that I'm recalling that part of our conversation, he did mention that. So the accumulators, the boost and reverse boost, you know, they all come in that kit. Now the valve doesn't want to come out. Dragging a little bit right here. I'll have to possibly clean that up. I mean, this is absurd. Alright, so what he did is he ground this to about halfway down, and then he made a couple of flats. I'm going to grind this all the way around so that we have full-time line to lube, so to speak. Alright, for the lockup valve, takes one spring, not two. I think the Sonic's kit, though, I see two springs in here. And again, valves loath to come out. All right, we're gonna chuck this up on a lathe. We have a lot of wear here where the slide works. Or was working. That's normal. So let's see, we have a 10 vein pump. This is a new pump kit. And I see a Teflon bushing. We have a one spring setup. Okay, this rotor guide has seen better days. We'll put a new one on. So 10 vein pumps, in my opinion, are more than sufficient for like pretty much every application. I know there's guys out there that insist that you do the 13 vein upgrade, or that's what they call it, an upgrade. I'm not convinced it is an upgrade. I don't know. You know, you be the judge, but I don't believe it to be necessary. These veins look new to me, so it looks like he went and installed, at very minimum, some new components in the pump assembly. Okay, the slide looks a little bit worn, but not anything I'd be concerned about. Real high RPM, you can run billet rotors. You know, they are a popular upgrade for anything super heavy duty or real high performance. I got your pump O-ring. Okay, incidentally, if you have a 4L60E pump body from a 93, 94, you can install it into a 700R4, it'll work. Alright, he has this, the Teflon seal here in the pump body, so we'll put another one, a brand new one in here. And of course a new seal. Alright, so I think I'm going to be a little bit challenged again. Alright, let's see if I can get this drum out so we can look at it. Pump the case. Okay, that took a lot longer than it should have, but that's what happens when you have kind of an issue plus someone that barely knows what the hell they're doing behind the controls. So the band looks in good shape. Got a little flitched over here. I'm gonna put a new band in it. I mean, I'm not gonna reuse any of the soft parts in here. I'll check the forward in a minute. All right, let's see what, if anything, happened to this clutch. Nothing, apparently. So what I'm guessing here is that the fluid loss or leak where that sealing ring was cut created so much of a leak that it just, you know, the clutch never actually had a chance to apply. So as far as I know, we only put it in reverse once, but it may have been twice. The other possibility is that I actually caused that that thing to be cut when I was taking the drum out or taking the pump out, but I don't think so. Okay, these steels look in good shape. He did put a steel module in here. There is some scoring on them, especially this one here. I may recommend that he upgrade to late 4L60E tubular steels. Okay, the bushings look new. I don't feel any grooves worn into the inner diameter. And the band surface looks new. We have basically almost no wear on the lugs. So I'm guessing this is a new AC Delco drum. If not new, actually, now let me take that back. I see some wear here. Looks like he may have prepped this with sandpaper, which this is a very nice prep job if so, because there's almost no glazing. In fact, like I said, I thought it was new at first glance, but it wouldn't have this much wear visually in the sealing ring area if it was, and it's got some wear on the lugs. So again, it's me not paying attention. All right, forward drum. So let's see what selective spacer he has in here. And how thick it is. Okay, so he's got a shim and a 71 thou spacer. I think those shims are like 15 thou. They come in the zip kit, which it's not mandatory you install them. They're there if you need them. So it could be that he thought that they were like required. or essential. This is, looks like 101 thousandths of an inch thick. $15 thou. So, I mean, yeah, 15 thousandths. So the fitment into the case between the pump and the two drums, and basically everything else along the center line of the barrel of the case, was likely an interference fit. So that's not good. And we see we have some material here, like something failed in this unit pretty significantly. I mean, seen some ground up metal in the case. I see some, looks like some evidence of contact here as well. Something scraping. Let me fire up the compressor. We'll check this drum, make sure it's okay. It's not leaking here where the shaft is pressed into it. And assuming it's okay, you know, we'll further inspect it on teardown to see if we would reuse it or if we would replace it. All right, let's go ahead and put a little bit of fluid here in the pocket. You know, about that much is all you need. And then I like to start with my 2-3 feed that's going to be here, and then the forward feed is here, and then your coast clutch feed's here, and you plug the forward feed with your finger or thumb when you introduce air into the coast clutch feed. So I'm looking for any kind of bubbles. Any bubbles welling up from the very base of the input shaft. 75 psi, that's what I'm using. And we see a lot of bubbles. Okay, we got a bubble bath down there. And that's with my shitty nozzle. The rubber tip's coming apart. I'm gonna have to get another one. So this drum's no good. Let's check the forward feed. Okay, no issues there. Now coast clutch. Okay, no issues there, but the 2-3 feed is leaky, so this drum will need to be replaced. Okay, I moved you over to the end of the bench where we can stick the forward drum into the hole. So he's got load release springs installed. Seeing a lot of clearance in here. It is very much looking unnatural. So these are pretty much smoked. And you see all the heat sustained. So this tells me the TV cable was not set up correctly, and the soft shifting was due to insufficient line pressure charge in the apply circuits, particularly the 2-3. Okay, they smell bad. These steels are no good. And then as far as the apply plate setup, we have, this is considered a selective. Then we have the apply plate itself, smoked. And then the support ring. So that thing had like 125, 130 thousandths clearance. You want to set these drums up, or this pack I should say, with no more than about 50 thousandths clearance, and that doesn't matter, you know, or irrespective of how many clutch plates that you install, you know, whatever setup you're running. And I have a video on 3/4 clutch setup, upgrades, and, you know, all the different considerations you need to take into account when building up a 3/4 clutch stack and a 700R4 4L60E. But, you know, your clearance is first and foremost. 35 to 50 thousandths is an excellent target range. Again, doesn't matter if you're running your standard 6 friction stack up, a 7 clutch, an 8, 9, or even 10 clutch. Alright, and if you're going to run it real tight, say 40 thousandths or less, install the load release springs. Around 45 thousandths is when I would start to consider leaving them out. If the clearance is between 50 and 60, 60 is the absolute max you want in this pack, then I would leave them out. Alright, let's get at the forward clutch. And if you can see into the drum, you'll notice a plastic seal there for the input-output shaft junction. It's a big no-no. You don't ever want to install the plastic seals because they tend to allow way too much otherwise gear lube oil to pass by the circuit, leak past it, because they simply don't seal. So a lot of heat sustained. Some slippage there. Okay, this is your forward sprag assembly, freewheel clockwise, locks counterclockwise. This is going to be your forward clutch hub. So the outer race and then the inner race is this portion. So when you're holding it like this, the forward clutch hub has to spin clockwise and lock counterclockwise. Given the amount of heat sustained, regardless if he put a new 29 element Borg Warner assembly into this sprag gear, we're going to replace it. And I believe he did. This looks new to me. Let's see if it's got cross hatching. No cross hatching, but the surface looks okay. We'll introduce cross hatching with some 320 to 400 grit sandpaper prior to reassembling this on overhaul. So look at that race. The race looks good. Watch out for scoring up here. You get some scoring sometimes, real bad. It'll have almost like a machined groove cut into this very top, maybe, I don't know, 15th or so of the entire diameter of the race. I see that from time to time on 700R4s, 4L60Es. And another thing I'm going to do is replace the forward thrust bearing, you know, the bearing that actually sat in the pocket there on the other side of this drum, on the forward facing side of it, because this thing had like basically no end play and that bearing was under a lot of stress. Maybe replace all the bearings in here, to be honest. Okay, new steel module for your forward. Here is your cushion plate or wave plate, Borg Warner module. These frictions look okay. So the pressure plate or, you know, backing plate needs to be prepped. I like 400 grit sandpaper, go all the way around. You can use a wafer pad with an angle grinder too. That's fine. So again, big no-no. Look how hard that is. We always install a 4L60E Viton rubber seal here. It's like a lot of heat sustained, unless this was like this previous. Don't know that it was. No idea. Okay, one thing we see in here is the reuse of these aluminum drum pistons. The forward, the coast clutch, and the most likely the third clutch piston. They will be replaced with bonded steel and rubber pistons from 97 and up 4L60E, along with the matching return spring assembly for the forward. This will go away. So I'll take this all apart and we'll look at it during the autopsy phase. I want to get the rest of this case emptied so that we can get everything cleaned up. Okay, let's get the case evacuated. So we have our sun gear. Let's see if the bushings were replaced. I think they were. I'll have to check with him. Yeah, these look new to me. He said he replaced the bushings, so. Alright, that sounds a little off, but could be any number of things going on. Get your 90-degree snap ring pliers and go ahead and remove your output shaft to front planet snap ring. A new one will come in the kit, though that's probably new as well. You may have installed a Sun Gear smart shell, rather. Sonic smart shell. Can't even speak anymore. Here is the rear sun gear. Notice the placement of the bushing. The bushing needs to be all the way down into the recess where it comes to the stop. Okay. There may be instructions to place this here. The problem with doing this on a factory bushing is that this likes to walk, especially if there's any lubrication issues at all in that area. That bushing will walk out and will, you know, do a lot of damage to the gear train. So he did install the smart shell. Very smart on his part. Best sun shell on the market for these transmissions. Front planet. 4-pinion planets are perfectly fine for almost any application. The 5-pinion planets, I'll be honest, their efficacy and argument for any situation to me is marginal. And that bearing seems okay. So I think that bushing is new, and this bushing looks new. What I'm going to have him do here, though, is I'm going to have him upgrade to a 03 and up 4L60E reaction shaft, get rid of this Babbitt thrust washer, and go with the Torrington bearing that came on these. Stabbing myself with the pick. Come on. Alright, check teeth, make sure they're not damaged in any way, shape, or form. Same with the lugs. Same with the lugs over here. A lot of times I'll see lugs that are heavily worn and they have like steps or grooves cut into them. If so, you're going to have delayed engagements into third gear or very bumpy shifting because the clutch pack's getting caught on those lugs. So if you see that, just replace that hub. New bushing, yep. Check these splines, make sure they're not worn out. Same here with the engagement splines for the hub. They look fine to me. Alright, we need to get our long screwdriver so that we can withdraw the center support snap ring. Okay, what I'm looking for here, or you know, where I was looking inside the case, I wanted to see if he had overlapped the anti-clunk spring with one of the ends of the snap rings. And he hadn't. He's very close on one end, but he avoided doing that, which is good. You don't want to overlap the anti-clunk spring with any of the two ends of the snap ring, because if you do, you actually run the risk of having this snap ring popped out by the anti-clunk spring. Seen it a couple of times. It's not super common. I've seen factory 4L60Es come in where there's an overlap. You know, where the one of these two ends is overlapping the anti-clunk spring. Okay, so now what I need to do is actually pound on the back of the output shaft to allow everything else, including the shaft, to come forward and exit the front of the case. So let me kind of clear some space here, get some of this other crap out of the way. This stuff can go right in the trash. Alright, going to use a rubber mallet. And I'm just going to pound on the back of the output shaft until everything else comes forward. Okay, looks like we got everything. All right, let's take a closer look at these parts. Center support. One absolutely smoked low reverse clutch pack. Alright, there we go. Look at that. Smoked. Now he did weld, or somebody did, welded the pinions here. This is a very good idea. It ensures that they don't pop out under extreme RPM or otherwise intense, usage. So welding these, because these will pop out, the rear planet takes a ton of stress on takeoff. So, all right. So we got a steel plate, another steel plate, which used to be a friction plate, steel. Former friction, now currently steel. Steel. Now steel. Steel. One friction, totally burnt. Steel and cushion plate. So now we know why there was a delayed engagement, but we don't know why this clutch burned so bad. So we will only know that when we get the piston out of the case. So let's have a look at the shaft itself. It is very stubby. Appears to be unharmed. And take a closer look at it once it's clean. It's the ring gear or the bearing. Alright, all these bearings back here are going to need to be replaced. Again, I'll take a closer look at that once I've had a chance to clean it off. I mean, he was only in reverse for, momentarily, basically, to back it out of his shop and then maybe one or two other times, and that's it. I mean, like he said, or like he told me, it has at most 20 miles on it. The transmission has at most 20 miles since he installed it. Okay, so for the transmission case, it'll obviously need to be completely cleaned out. And then what I need to do is install my tool so that I can compress the return spring assembly for low reverse, get the snap ring in there, and pop the piston out with compressed air. All right. Okay, if this is still stuck on the snap ring groove, just tap it with a long screwdriver and it'll come right out. And it's not going to fly up and hit you in the face unless you have your head literally stuck into the barrel of the case. As if you're putting your head into the mouth of an alligator or something. Okay, now what we're going to do is go ahead and apply air into the low reverse feed. Okay, your low reverse feed is going to be here. I'm going to apply air and we're going to pop the piston right out. Now, a priori, I'm going to speculate that he cut a, possibly cut a sealing ring, one of these machine cut rubber sealing rings, on the piston on the way in. That's possible. The check ball misplacement by itself could possibly cause this, but in all the catastrophic low reverse clutch pack failures I've seen, there's either the innermost sealing, your machine cut seal is hardened, like to the point where it's just not allowing fluid to blow by, but there's enough pressure still to partially apply the clutch, or on a new transmission or fresh rebuild, you know, somebody inadvertently lacerated one of those machine cut rubber sealing rings. Okay, let's see. See right there? That's cut. It's not cut bad, but it's cut. I could feel it. And we still have a lot of trace assembly lube, so you gotta wipe that away. But right here is what I'm thinking is the primary culprit in the failure of this clutch. Alright, let me see if I can dig this accumulator piston out of here. Okay, so your accumulator feed is right where my nozzle is. Sorry about that. Okay, and then Sonex has you plug this port here with a check ball, and they do the same for the 1-2 accumulator. Alright, let me see if that'll hold up. So you want to put air right here in the housing. Pop out. The 1-2 accumulator piston. Now these pistons are both the same. So you see the check ball that was installed. This has to be done so that you don't have a massive leak in the accumulator circuit, because otherwise you'll have your pin here. Now this is a 4L60E housing. I mean, you can use it, but in my opinion, I like to keep the correct vintage of housing with the corresponding transmission. So I'm going to see if I can find him a good condition large hole accumulator housing and run that. But this housing is in good shape. Otherwise, it's been modified specifically for use with these Sonex pistons. So, you know, if we have to reuse it, we'll reuse it. Alright, that's a teardown. Let me get everything cleaned up, and then we'll go ahead and we'll take a closer look at all the parts and components. And at that point, I'll go ahead and discuss what I'm going to recommend to him as far as replacements and upgrades. Alright, it's a couple hours later. I have everything all cleaned up on the bench, and unfortunately, this is going to be on the stout side of painful when it comes to the amount of hard parts that we have to replace in this transmission. The failure that you saw at low reverse was catastrophic, and you know it took out the center support. We got to replace that, and it may necessitate replacing the case, which you'll see in a little bit when I show you all the scoring on the sealing surfaces for the low reverse pistons. So just real quick, I'm not going to spend a ton of time. I want to basically spend what time I do have going over specifically what happened cause and effect wise, and showing you the parts that are no good versus just boiling the ocean again with everything else. So pump body, heavily scored. Okay, this has to be milled, resurfaced. One thing I always recommend you do is wallow out the drain back 5/16. Okay, you want to drill it all the way down to the very end, but whatever you do, don't actually penetrate the casting. I mean, that's very difficult to do. And then here, go in with a 5/16 drill and you know, even it out, so to speak. And that'll give you very nice drain back characteristics at pretty much any RPM. You know, it'll be able to handle it. And then we'll put another Sonex Teflon bushing here. We're also going to put the same bushing in the rear position on a reverse input drum. So that has to be machined. So when it comes to this sealing ring here, okay, and I'll be honest, at this time I haven't looked at the footage of the teardown portion, so I can't remember if this was, you know, what position this was on, whether it was the here, the base, or the rearward most position. Usually when these things get caught up like this and they get cut, it's going to be on this position here, okay, the the bottom sealing ring. The top sealing ring usually gets by, but then it gets hung up on the bottom sealing ring. For whatever reason, I have no idea. This has to be resurfaced. I mean, you can clearly see, and I can clearly feel, scoring and undulation in the surface. Again, that is all contaminant, particulate debris from the low reverse clutch pack failure. Now, as I mentioned earlier, it's possible that I could have done this, taken the drums out, or taken the pump out rather. That was very clumsily done. So the reverse input clutch pack wasn't burnt, so it either didn't apply at all, or if it did apply, it was able to apply despite this being torn like this. So I'm going to conclude that this is my fault, at least for now, as I'm filming this. When I go and edit this video and, you know, I get a chance to see everything, maybe my opinion will change. If so, I'll annotate. But as of right now, I'm going to blame myself for that particular mishap. But what I can't blame myself for, and what is the, you know, primary failure mode in this transmission, is the low reverse clutch pack, and specifically the damage that was done on installation on the outermost machine cut seal here. Okay, this is basically the beginning and the end of the problem for low reverse. And unfortunately, this is all too easy to do, especially if you're new to rebuilding these transmissions, because you don't have the body of reps, if you will, to get a good feel for what that piston should feel like to you as you're smacking it in using the hammer in either a very long drift or the output shaft, what that should feel like going in. I mean, it really should be gradual, 1, 2, 3, 4, 5 smacks, and that should be it. 6 at most. So if he was pounding away and pounding away, I mean, you know, he may have built a couple of transmissions prior to this, not in a very long time. He won't have that, you know, that sense of direction, that feel, if you will. So nothing's going to tell him to stop and reevaluate and check. He may just have thought, hey, this is normal. I mean, it takes some energy and some effort to get this thing seated into the rear of the case. I mean, this is me speculating based on my own personal experience, thinking way back when I first started rebuilding these units over 10 years ago, and it took me a while to get a good feel for how the low reverse piston should seat, how it should feel going in versus you know, what wrong or problem feels like per se. You know, how to tell when you need to stop, pull it back out, and check it. Okay, these seals are fine. Alright, no damage done to them. But the outermost seal, unfortunately, that is all it takes to completely smoke a clutch pack. Okay, it had enough pressure to partially clamp down on that clutch. So this is the clutch itself. I mean, you saw it earlier, no reason to rehash it. But when you have a failure like that, you really have to scrutinize the center support. And as you can see, all the way around, especially down here, significant scoring. Alright, there's no point in trying to rehabilitate this. It's junk. Has to go. You can see some of the bluing. So even if it didn't have this scoring, it has bluing. More than likely, it's warped. I mean, you can't visually tell, but you know, if I imagine I put a straight edge to it, I would then put a little small level on top of the straight edge on a perfectly flat surface. More than likely, I'd see some warpage there. Okay, the inner race for the Sonic Smart Shell is in good shape. That's a good thing because they're $150 a pop. So if this race was no good, I don't have like a, you know, bunch of extra races, so we'd have to go and buy another one. For your rear sun gear, again, I mentioned this earlier, but we'll install wide sun gear bushing, little Loctite on the outer diameter of the bushing to keep it 100% secure in that position, because those bushings do like to walk. Almost every single 700R4 4L60E I take apart, that bushing has moved to some extent. Alright, sun gear bushing for the front sun gear is a little bit too far in. Okay, it's coming very, very close to this lubrication port right here. I like to have them just below the top of the deck surface there. That's just the way I like to do it, but I wouldn't recommend going this far into it. Alright, the rest of the gear train's fine. The planetary carriers are fine. No big deal. Alright, so let's talk about the front of the transmission, particularly all the heat sustained at the area of the forward and coast clutches. So both show signs of extensive heat exposure, heat soaking. Alright, interestingly enough, the steel plates are in perfect shape. Okay, a ton of heat here on the wave plate or cushion plate, but other than the scoring that you see, the steel module for the forward clutch is fine, and they can be cleaned up. Your 3/4, again, kind of an unconventional stack up. So you have a selective, and then you had the support, and then you had the apply plate, and then you had the selective like this. I mean, this is fine technically. I don't like to do it that way, but it's not going to harm anything. And then of course you have your backing plate. So none of those things are going to go back in. I don't trust them. I mean, the 3/4 pack got a little bit hot. He didn't mention anything slipping in third gear or in fourth, but there was an incredible amount of clearance in that clutch pack. It looked like well over 100 thousandths to me. So I think I'm going to do a 4L65E module. All the hardware, the frictions, the steels, and it'll give them a 7 clutch high energy stack, and we'll run that clearance to about 30 to 35 thousandths. Alright, for drum pistons, don't ever reuse these. The aluminum for the third clutch and the coast clutch piston, these are actually not problematic. I don't really see too many issues with them. Occasionally I'll see, you know, a worn out or hardened lip seal, but the problem is in the forward piston, or with the forward piston. They like to crack along the lugs and along the base right here. And I see that from time to time, enough to know it's a common pattern failure. So all 700R4s and 4L60Es through 1996 receive bonded steel and rubber pistons along with the corresponding late model return spring that went into the 4L60Es from 97 onward. And that is my standard policy when it comes to that. I don't ever reuse these aluminum pistons. I don't like them. They're no good. Okay, our apply ring. Notice that this is an unstamped apply ring, meaning there's no number stamped on any of these shoulders. Sometimes on the late model 700s, you'll see that. And one thing that I didn't mention in my 3/4 upgrades video, if you watch that, is that the unmarked apply rings usually indicate the longest or tallest apply ring from the base to the tops of the legs, as you see it here. However, some of these unmarked apply rings were actually shorter than any other. So this could have contributed to his excessive clearance in the 3/4 clutch. We may have a short apply ring, and if we do, I'm actually going to keep it and I'll swap to a number 7 or number 4, which I have plenty of those, but I do not have any unmarked apply rings that are of the short variant. So it's just good reference to have. Alright, Reverse input, again, no serious harm done. The clutches and the steel plates along with the cushion plate do not show any signs of stress. No big deal. So, steel module wise, I think I'm going to do a forward steel module. I mean, I know I can clean those forward steels up, but I'm not going to bother. I mean, it's just, you know, I don't feel like spending the time doing it. I have a fresh steel module, so that's what we're going to go with. And then the coast clutches are fine. As far as friction module, I'm going to do all high energies in here, Alto or Borg Warner. It's good for a heavy duty build that sees the street. If you were doing a lot of racing, if this truck was going down the track or doing something you know, equally intense, then I would probably opt for maybe some Alto Reds or Rebestis blue plates, especially in the 3/4 pack. But for just a daily driven street truck or just, you know, occasional cruising and a little bit of towing, working, hauling, the Borg Warner or the Alto high energies are fine. Okay, I'm going to put bearings because, again, the amount of heat that this thing's seen, it's just good practice to replace the bearings. Same with most of the bushings. Most of the bushings are going to get replaced, if not all of them. And I mentioned the Sonex Teflon pump body bushing there in the rear position of the reverse input drum. It goes right here, and then you have your standard bushing back here. So these have scoring, they're going to get replaced. And the pump, this is scored up pretty bad, it's getting replaced. And then in the rear stator, I'm surprised that I'm not seeing a Sonex bushing here. So I'm going to have him, or at least propose to him, that we put performance bushings in the pump and reverse input drum. Sonex has like a Teflon red coated bushing that goes there. I'm surprised it wasn't installed because I believe it is in their zip kit for the 700R4. I know it is for the 4L60Es, and it's the exact same bushing. Okay, what else? The smart shell, no damage done. It's going to need an input drum. The input drum was leaking, as you saw earlier. These input drums are not terribly expensive, so, you know, no big deal to go and get another one. Okay, the Sonex servo is in good shape. So here are all the sealing rings that go to that servo, and that's just the 4th gear, because he has the regular Corvette 2nd gear servo. So this is what the assembly looks like all apart. Here are all the different pieces to it and how they go. And yeah, I know it's not quite cooperating with me here, but there we go. So just like that. He has the D-ring Viton seals on the servo for the 2nd gear. His Corvette servo is in good shape. There's no reason not to reuse it. Same with the accumulator pistons. They look in good shape. They can go back in. This is the large hole piston. It has wear for the forward accumulator. We're going to put a new one. The governor. Again, no movement in the valve. That could have been a contributor to his very late shifting. If you don't see that valve moving, then just take it out and polish the board. No big deal. Okay, wiring harness. We're just going to replace it with a Rostra. I don't think I need to get another internal-external lockup kit. Whatever he has will work with the native wiring harness. And then, luckily, this output shaft escaped unscathed. Those are not cheap. Not cheap at all. Okay, we can put the 1.2 accumulator housing back in. Yeah, it's technically a 4L60E, but it'll still work. It just depends on how we want to drill the spacer plate. So I know he wants to go a little bit more aggressive on that. That's no problem. We'll go ahead and we'll take care of that on reassembly. So that is a rundown of all the components in or on the case that need to be replaced. So now let's take a quick look at the case, and I'll show you what concerns me the most once I took a look at it after cleaning. Okay, there's 3 things I want to touch on with the case. First is going to be the Sonex servo release check valve that's installed. It comes in all their kits, and I don't use it too much individually, but I will install it when using a zip kit or a SureCure kit or something of that nature. And I'll do a separate video on it, because what it's designed to do is improve upon the timing and sequencing of events around the 2-3 shift and 3-2 downshift. And basically it kind of, I don't want to say fixes, but it improves upon that exchange when it comes to timing by ensuring integrity in the 2-3 release and the 2-3 apply circuits. So suffice to say, it's not a fix for a leaking third accumulator check ball capsule. So you'll need to test your check ball capsule if you plan on using this, because it's predicated on a capsule that's in good serviceable working condition. Okay. The second thing I'll touch on is going to be this little air check tool right here. This is going to be for your governor bore. So how this works is you insert the tool into the governor bore, and the hollow stem mates or slides over the gear alignment pin or support pin in the case, and then you're going to put air right here. Okay, and what you're looking for, what you're trying to detect, is air leaking past the pin here, the check tool, which would tell you that this bore is heavily worn out. Now, I don't see this very often in any transmission that takes this style of governor, the TH400s and that whole family, the 350 and the 700R4. So the 204R, this doesn't apply to, because that takes a completely different style and design of governor. So I'm going to put air here. We're going to feel for any air whooshing past the check tool, because if we do feel that, then that would tell us the bore is worn, and then we would have to ream this bore and install a repair bushing to fix this problem. Okay. What I'm doing is I'm putting my fingers all the way around the diameter of the check tool to feel for any air that might be whooshing out. And I don't feel anything. I already did this test off camera, but I just wanted to demonstrate it for you so that, if you do a lot of 700s or TH350s, 400s, you may want to have this tool handy, because you'll use it to check all your cases when they're cleaned off and dry. All right, so the third thing, and to me the most concerning by far of the three things that I want to touch on with this case, is the damage that is done to the outermost sealing ring surface area for the low reverse piston. So I'll go ahead and reposition the camera, and then we'll take a closer look so you can see what I'm talking about, and you'll understand once you do why I'm thinking that this case is not going to be reusable. Okay, I know this is a tough angle, trying to see deep inside the case, but this is probably as good as it's going to get. So if you're looking in the area where I'm shining my flashlight, you can see the sealing surface for the low reverse piston's largest or outermost machine cut sealing ring. Okay, look at this area right here by the blade of the screwdriver. Okay, that is some heavy scoring. Heavy scoring. If I could feel it, I mean, it's like somebody took a cutoff tool to this sealing surface. Alright, let me spin the case around. There's a little more of it on the other side, on the 6 o'clock side of the case. I mean, that is heavy scoring where I just had my finger. So if I were to reinstall the low reverse piston, it seals, and then build up the whole transmission, ship it back to him, I would guess that he might get between, I don't know, 3 and 12 drive cycles out of this thing before he started having problems with reverse again, and losing it shortly thereafter. So, I mean, this is a catastrophic failure, and I mean, I'm going to take this case to my machinist to see if there's anything he can do to clean it up. My usual recourse, which is sandpaper, is not going to fly here. I mean, those are some deep divots down there. And so I'm going to see if there's anything that he has, any kind of, fixes that I'm completely unaware of, maybe work his magic, so to speak. But I would not hold my breath. So okay, to summarize our findings, we had 3 consequential missteps here during the assembly of this transmission that led to its untimely demise. Okay, the first 2, I would say, are a moderate level severity, but the last is, pretty high, high to severe. So the first was the lack of end play. You always want to set end play between 10 and 30 thousandths. In this case, we had a shim that was too thick, and then we had a washer, I should say, was too thick. And on top of that, we had a shim creating what I believe to be an interference fit between the pump, the back of the case, and all the rotating components therein. That led to a tremendous amount of heat built up into the forward drum. You saw that with the coast clutch and forward clutch pressure plates, as well as to some extent the 3/4 clutch pack. And that leads me to the second procedural error, and that was the setup of the 3/4 pack itself. I believe that pack started life with probably no less than 60 thousandths clearance. When we took the drum apart, it looked like it had about twice that much, maybe more. A lot of that's owing to the wear and the drag that clutch experienced, but suffice to say, you want to set your 3/4 pack up tight. 30 to 50 thousandths, 35 to 50 thou is where you want to be on the low end, and on the extreme high end, no greater than 60 thousandths, and that's only if you're running a 7 to 10 clutch stack up. By itself, it's not too consequential. I mean, if you have just 3/4 failure, he probably did not know to check the drum for leaks at the base of the shaft. That's not something that even I knew to do until I had one that came back to me literally twice before I figured it out. But suffice to say, the most consequential procedural error here was cutting that outer machine cut seal on the low reverse piston. That resulted in a catastrophic failure of the low reverse clutch. Tons and tons of contaminant being sent throughout the unit, scoring up everything, including the sealing surface for that piston at the base of the case, or the back of the case, I should say. And unfortunately, that is going to necessitate replacing the case itself, in addition to all of the other parts that this transmission is going to need. So I'm going to have to do a complete inventory of everything that we do have to replace. And given that he's in Illinois, and I'm just going to purely speculate here, this is wild-ass guessing on my part, but he might decide to say, look, I could probably get some a little bit more cost-effective locally. I don't want to be spending, upwards of $3,000 on a transmission, and, from somebody all the way out here, out west. So, again, just, guessing, if you will, trying to put myself in his shoes. He may have me just put it back together and send it back to him, and he'll pay the freight, meeting as is, and he'll treat it as a core so that he can purchase another unit, from somebody there. Or he may decide to have me go through this thing soup to nuts, and whatever the bill is, that that's what it is, and that's what he'll pay. So we'll see. If I have time, I'll do a follow-up video and let you know what ultimately happened, but suffice to say, it does need quite a lot of remediation. Now, it's not all bad for someone that doesn't do these transmissions all that often. I mean, number one, you have to give credit where credit is due, in the sense that he had the stones to take this project on himself. We all make mistakes. We're all human beings. Nobody's perfect, least of all me. Far be it from me to, criticize somebody other than beyond purely the dispassionate technical analysis and autopsy done on the unit. So I applaud him for taking it on and show a willingness to dive into something that's well outside of his comfort zone. With that said, he did do some things correct. I mean, he had good part selection. He installed the Sonics hydraulic kit, the zip kit. He understands how important hydraulics are to a function of an automatic transmission. He has the servo, he has the sun shell, and he did replace all the bushings. So again, some of the fundamentals were adhered to. He did try to recondition the reverse input drum. I don't know if he checked it for warpage, or maybe he didn't understand that
you can't really use a wide band with an imperfect surface or a drum that has some warpage in the center like this one does. Again, that all comes with experience, and if you don't have it, you can't really acquire all of it, years and years worth in, say, a couple of weeks or a month's worth of time trying to research in advance of diving into a project like this. So again, kudos to him for taking this on. So he asked me to tear it down, to inspect it, and to let him know what the problems were and what caused those problems. And we did that, and we identified the direct causes for all of his drivability symptoms. So I'll go ahead and report back to him, but if you made it this far, thank you so much for watching. I greatly appreciate all your viewership. If there's anything else you want me to talk about, any videos you want me to do on these transmissions, I'm always taking them in and overhauling them, so just let me know in the comments. Otherwise, enjoy the rest of your day or evening, and I look forward to seeing you on the next video. Thanks again.